activity today. Okay. So always we have to focus, okay, the given, okay.
Yeah.
So on these questions, the given is there all circles are tangent. Okay, tangent means what they have, right? One point intersection of one point. This is what we say point of tangency. Okay, tangent point or tangent point. So always we gotta focus, right? A tangent point and centers. Okay, when you
Yeah.
connect all these centers, they're gonna pass to a tangent point always. Okay, that's the
Okay.
point. Yeah. Okay, actually, which is what isosceles, right? Because B and C, the same size of the circle. Okay, age are different. Okay.
Okay.
All right, and also another one. Circle A, a little bigger one. Circle A has through the what center of D. Okay, center just pass the center in the middle over here, right? That's the center. Or maybe you can make the line over here. Okay, we're gonna use right these centers. Okay, all right. So we're gonna find the radius of a small circle B over here. So first of all, we need some variable, okay, to set up the equations.
Okay.
Okay, already they're asking you some things that is a variable. Okay, we can take this as R. Is it okay? All right. Okay, the next one. So wait, what is the length of AB? Can you see the AB? This is
1
center,
plus
right?
R.
Yeah. So let me see. Circle B and circle A, the radius is 1, right? This is the radius 1.
Yep.
This is what? 1 plus R. That's right, okay. So we use the one variable, so we need to find, okay, some equations with one variable, right?
Yeah.
And another one, maybe from here, we can find some things. What is the length of this one? We don't know, right?
Yeah.
We still don't know this one. So we need to use these centers. When you make the centers of this center already pass through the center of B over here, right? Okay. All right. Now that's fine. This is also one radius. Can you find the length of this side? Okay. Can you find the length of this one from here to here? I'm going to take this as what? D. Okay, F. F.
Okay.
This is B. BF. Can you find the length of BF? This is center of 1, right?
Yeah.
So from here, what is the length of this radius?
2.
2, right? Excellent. This is 2. What is the length this side? Still same as what R, right?
R. Yeah.
Okay, so what is the length this one? 2 minus R, right?
Okay.
Okay, that is 2 minus R. Okay, we got this one. Okay, how to make it clear, okay? So we have this one. This is R. This is 1 plus R. This is 1. This one is 2 minus R. Okay?
Okay.
Alright, now we're gonna apply some Pythagorean theorem. Okay? So using
Okay.
this one, using this too. Now we can find the length of this side, right?
Yeah.
So what is the square root? Hypotenuse squared, 2 minus R squared is 4 minus 4R plus R squared, right? And minus other leg square, R square. Okay, this is length this side. So R square out. This is actually 4 minus 4R. Okay, or you can simplify to 1 minus R, right?
Yeah.
Okay, that is the length this side. Now I'm going to write down this is better. This is 2, 1 minus R. Okay, now to this side, the value of R, we need to apply one more because we're going to use this one, right? This side we used already. Now the big right triangle, we try apply one more times Pythagorean theorem. This is 1 plus r. This is r. This is how much? 1 plus. I'm gonna write down. Okay. This is 1 plus 2, 1 minus r, right?
Yep.
Okay, now we just apply one more Pythagorean theorem. Okay, r square. This is r square plus 1 minus 2r, 1 minus r, n squared. That is equals to 1 plus r squared. It is okay?
Okay.
Alright. Now let's simplify. This is r squared. This is what? 1 minus 4, 1 minus r, and plus the square is what? 4 times? I'm gonna write down, okay, 1 minus r, it's okay.
Okay.
Yeah, and this one equals what is it? 1 plus 2r, n plus r squared. Okay, perfect. So r squared is out. 1 is out. We just got 2r over here, okay? This
Okay.
is actually how much? 4.
4 minus 4r.
4r. That is equals to 2r. And I'm gonna move this to the other side. That is better?
Okay.
Okay. 4, 1 minus r. Okay. Now 2r, 4r is what? When you take them out, 4 minus 6r, right?
Hmm.
Okay. So minus 2r minus 2 out. That is equals to 4, 1 minus r. Okay. Alright, now
Okay.
simplify a little, okay? Because both 3 terms is what even coefficient, okay? You can divide it by 2 to make it easy, okay? During the
Yeah.
work, always simplify, okay? So 4 minus 6i is actually 2 minus 3i. What is r? 3r, I'm sorry. I just finished with imaginary number, okay? Before the class. Minus, this is 2, 1 minus r, okay? Now you can make a square again, right?
Yeah.
Okay, square again. So, which is what is that? 4 minus 2 times negative 3 is negative 12r, and plus 3r squared is 9r squared equals 4 times 1 minus r, right?
Yeah.
Okay, now simplify. 9r squared, and this is it. I'm gonna simplify. 4 minus 4r. Okay, plus 4r is minus 8r, right?
Yeah.
Okay, and the plus 4 is out. Oh, simple. We don't need the factor, right?
Mm-hmm.
Just equals 0. There is no constant. Just r is a common. We know that r is a common. You don't have to put up it right ahead because r cannot be 0. Just divide by r is okay too, right?
Yep.
Okay. All right. So 9r minus 8 equals 0. R equals what? 8 over 9. Okay.
Mm-hmm.
Right. Or you need to focus the given. Okay. Not anything else. Okay. So this is why sometimes need a little more practice how we use the given. Okay. All right.
Okay.
So this is any questions on these questions?
No.
It's okay. All right. Very good. All right. Now another one. So we have a square ABCD, side length 2. This is 2. This is 2. And diameter. AB is a diameter. We have a semicircle there. And tangent, some line, tangent EC, okay, through what? AD. This is P. Okay, we have the 1 point of tangent over here. Alright. What is the length of a CE? Okay, from here to here, right? CE. This also was said what tangent. Okay. We know
Okay.
that, right? The tangent is when you have exterior point out of circles. Tangent is what? The line pass through the what? 1 point over what? On the circle, right? That is tangent. When
Okay.
you have 2 lines, 2 point of tangent, 2 intersections, this line we said secant. Okay, but this is tangent. We did already, okay? This tangent
Yeah.
always congruent. They are equal, okay? So we have to use this one, right? Okay.
Yeah.
So CE, okay, how we find this one? The question is, we're gonna find this length first, okay? This length first. This is x. This is also a tangent, from this one to the circle over here, right? The other circle over here. Another tangent over here, right? So tangent length, this is also x, right? Okay, very good.
Okay.
What is the length of C? I'm going to use this is CDEF. Can you find the length of CF?
CF.
Yeah. That is also tangent. Where is what? Corresponding tangent, another tangent. This is extra point. You got two tangent. This one?
Is it 2?
Yeah, that is a tangent is congruent. They're already equal, right? Equal length. This is also 2 from here to. That's true, right?
Yeah.
Okay. Now, we got some number over here. We got what some length CF with in terms of x. Maybe you can try to find this length in terms of x. Okay, right? Can you see that?
Yeah.
What is the length of DE in terms of x? 2. Whole thing is 2. From here to here is x. From here to here is how much? 2 minus
2 minus x.
That's right, 2 minus x. 2 minus x. Now we got all three sides on this right triangle. Okay, because this is a square, right? All angles are 90 degrees.
Yep.
Now, all sides is expressed, okay, in terms of x or constant already. So using Pythagorean theorem, you can find the value of x definitely, right? Okay, now we apply Pythagorean theorem again. One more. Alright, 2 square, 4 plus this one square is how much? 4 minus 4x plus x squared. It's okay. I just write squared already, okay? This is 2 plus x is what is it? 4 plus 4x plus x squared, right? This is 2 plus x squared. Okay. Now from here we can find x squared out. Oh, x squared out, and now we got only one linear, right? Okay, so linear, so easy one. Okay, just to separate. Plus 4x plus 4x right here. 8x equals 1 point out 4 over, that's 1 point out, that's it. So when we still have a 4 over here, right?
Yep.
That's the equations. So what is the value of x? You can divide it by 8. X equals 1/2, isn't it?
Yeah.
Yeah, this length is 1/2. But we need to find the length of a CE from here to here, right? So 1/2 plus 2. Okay, so 1/2 and plus 2. Plus 2 is about 4 over 2. So total length will be 5 over 2. But that is not hard, okay?
Okay.
Yeah, we just apply the tangent, okay?
Yeah.
So using this tangent length is always equal, okay, from any point of outside of circles. Okay, using this one, we just apply, okay, one more Pythagorean theorem, okay? All right. So we have choice D is the answer, okay?
Yep.
All right. Okay, okay. Every time, okay, you have to completely understand the questions, okay? Because MC is very similar, okay? Okay, every years, okay, they give a very similar questions, but not exactly the same, okay?
Yeah.
Similar means what? Same,
Same concept.
Yeah, same concept. That's it, okay? So when you have a tangent, looks like, think about these questions, okay?
Okay.
All right, very good. Number 8. All right, we have, this is, we said, analysis, okay, the ring, right? The ring up here. This is the center, okay? Center is concentric. We said concentric, okay? Yeah. So we're going to express the shaded regions, okay, in terms of like A or B or C or D. I think this is not hard, okay?
Okay.
From here to here, length is B over here, right? I think that's correct, okay? Yeah, B. What is the area of this large circle? Pi B squared. Okay, that's true, right?
Yeah.
What is the area of the small circle? That is C, right? Okay, minus pi C squared. But actually, we don't have the answer like this one. A little simplify, okay? A little simplify, so we're gonna find the one single variable. So take a look, pi and b squared minus c squared. What is the b squared minus c squared? That is a squared, right? Using Pythagorean theorem.
Oh, yeah.
That's right. Oh yeah, this one can be expressed what? A squared. That's it. Okay? We just reduced the variable. So choice A stands, okay? Make sense?
Yeah.
Right. Okay, this is not hard, okay? Alright, number 9. I recorded this one. Okay, I think I recorded. Was I there? Okay. Right, we have another circle. So BC is 2 times AC, right? So this is 1, this is 2, something like that, right? Okay.
Yeah.
What is the ratio? But maybe you can use the unit ratio, okay? This is 1, this is 2. You can use this as their dimensions. Alright, okay. So we have a perpendicular line. So these two lengths must be equal, right? And this is center over here. Okay. Another one is the DE is the second diameter. Okay, this is diameter. Okay, pass through. Okay. What is the ratio of area of triangle DEC? Triangle DC. Where is DC? This triangle. Over area of a triangle ABD. ABD. Large one. Okay. How we find this one? Can you find the length of this side? You know that the intersection, right? Two chords. Do you remember? I think it doesn't have to be always a circle, perpendicular. Okay, anything is okay. This is A. This is B. This is C. This is D. Okay, so A times B equals C times D, isn't it? Do you remember this one?
I think, yeah.
Yeah, you have to, right? Because when you make the line over here, this is for the same arc, inscribed angles are equal, right? These two angles are equals. Now take a look at the other arc. Other side arc for the same arc, it's inscribed angle also equal. So angle congruent, right? So these two triangles are always similar, right?
Yeah.
But in this case, corresponding side, A corresponding side is C, not B. Okay, you gotta be careful because these two angles are congruent, right? So A over C is a corresponding side, and D over B corresponding side. Okay, now you can multiply crossway, so A times B equals what? C times D. Okay?
Okay.
But in this case, this one is what? Perpendicular over here. The other side is equal, right? So this is X, this is also X. Right?
Yeah.
Same length, isn't it? So what is that? 1 times 2 equals 1 times 2 equals actually X times X, X squared, right?
Yep.
X equals actually red 2. Okay, this is red 2. Okay, so what is the length of a triangle ABD? 3 times, base is 3. 3 times, height is red 2, and divided by 2, right?
Yeah.
That's the area of a triangle ABD. Okay. Now let's find the triangle. This one, ABD. No. Yeah, ABD and DCE, right? Now you're gonna find this length. This is center is what? From here, the total length of diameter is 1 plus 2 is what? 3. When you divide by 2, that is what? 1.5, okay?
Okay.
This is a 1.5. But from here to here is 1. This side is 1.5, okay? That's it. So this triangle area is how much? 0.5 times 1 over 2, right? That's 0.5 times red 2.
Yep.
And divided by 2 again, times 2, right? That's that.
Mhm.
What about the other side? What about the other side? Also, this is base. This is same length over here, that's height. Okay. When you over here, when you make another line over here, because that just pass through the what? Center, this triangle, congruent, right?
Yeah.
It's okay? Because the
Mm.
angle, this is radius, right? Okay, right angle, you know that this is when two angles are right angles, okay? Hypotenuse leg, isn't it? HL, congruent HL, right?
Yeah.
Exactly, these two triangles are congruent. So this is 0.5, this is also 0.5, right?
Yeah.
So this length should be equals to what? Red 2, same thing. So this height also red 2, right? Same thing, this is exactly the same height,
Mhm.
okay? Yeah.
Okay.
So this area equals this area, right? Same area. So we're gonna times 2 again. Okay, so this is out. Okay, so actually 1 over 2, right? The red 2 over 2 over 3 red 2 and 2. When you divide it by, this is out. Okay, red 2 is out. We got what?
Yep.
1/3 is the answer, okay? Right, choice C is the answer. Any questions on this?
No.
It's okay? Alright.
Yep.
Okay, now move on number 10 over here. Also, when you have right circles, always, okay, try to use the center, okay? When you
Okay.
connect what the center to center, already they pass through the what? Point of a tangent, okay?
Yep.
Right, so this is S, this is R. So when you make a, maybe this is 2R over here. So we're gonna find, okay, some equation between R and S, right?
Yep.
How we find this one? Always we need to think about right triangle using Pythagorean theorem. I'm gonna use this one, make the line over here. This is perpendicular, right?
Mhm.
This is R. I'm gonna make the line over here. You can make any triangle, doesn't matter. You can make up to here, doesn't matter. Anyway, this is a right triangle. This is also right triangle, okay? It doesn't matter. You can use any right triangle. I'm gonna use a simple one. Okay?
Okay.
Because we know that this length is S. This length is S. From here to here, total is R. When take off S is what? This length will be R minus S. It's okay?
Okay.
Alright. Very good. What is the length of this one? Nick, can you find the length of this one? From here to here, still R. That's the radius. We're gonna take off this one, right?
Yeah.
One section is R, another, I'm sorry, S, 3S. So take up 3S from R, right? R
Yep.
minus 3S. If we choose this point, R minus just S, okay?
Okay.
Right. And also now this one is okay. This is S, this is R, all the way down over here, this is R plus S. That's it, okay? That's it.
Okay.
So, we use two variables, okay? R and S. But it doesn't matter because what? we're gonna find what the ratio. We don't have to find what the value of r, the value of s individually. Okay, to find the ratio with one equation, okay, two variable is okay, right? Okay, no problem at all. Okay, when we're gonna find the ratio, okay, we just find the relation between r and s. That's it. Now apply Pythagorean theorem. This side leg, another leg square, right? So r minus s squared plus r minus 3s squared, that is equals r plus s squared. That's it, okay? Now let's find the relation, right, between r and s. So now simplify. R squared 2rs s squared r squared 6rs 3s squared 9s squared, that is equals r squared 2rs and s squared. Right? Okay. Now r squared s squared out. R squared s squared out. R squared s squared out. So we have what? R squared here. 2rs total is what? 8 negative 8r s 2rs is minus 2rs. Okay, this is out. So r squared minus 10rs, isn't it?
Yeah.
It's okay. And plus 9s squared. That is equal to 0. Alright? But this one can be factored, right? Sum is 10 and product is 9. But two numbers will be negative 9 and negative 1, right? So r minus s, r minus 9s, that is equal to 0. That's the final equations. From here, r cannot be s. You know that, right?
Yeah.
S is very small, r is big. This one cannot be 0. The only thing is what? To make a 0, this one. If r equals 9s, that's working. Okay? Alright, r is 9 times. Put this number up there. R is 9s, but the denominator is still s. Simplify, it's going to be 9. Okay? Or you can use the way s is 1, r is 9. You can use this number too. When s is 1, r is 9. R is 9, s is 1. It's okay?
Yeah.
Alright. And also one more thing is this is another scares. Because they're gonna ask you to find r over s. But in this case, we can also use what? One variable. What that means, you can set the r is 1. It's okay, right? If r is 1, just find the value of r, that's the ratio. R is 1. Okay? You can try this one later, okay, after class. It's gonna give you right the same answer, but a little, okay, make it a simpler way, okay? Easier way. You can try, okay? So you can set s equals 1. Okay, so the equation must be what? What is it? R minus 1, right? R minus 1 squared. R minus 3 squared. R plus 1 squared. Just solve it. Looks like it's so easy, isn't it?
Yeah.
Right? Okay, we finished this one together, okay? Yes. R squared minus 2r plus 1. This is what? R squared minus 6r plus 9. Right inside equals what? R squared plus 2r plus 1, isn't it? We just find what the value of r, right? Because s is 1. We just find the value of r. That's the answer. Okay? So this is what? 2r squared 8r plus 10 equals this one. So r squared is one side, r squared minus 10r plus 9 equals 0, okay? So r minus 1, r minus 9 equals 0. R cannot be 1, right? Because s is 1, r should be greater than 1. This one cannot be 0. So r is 9, okay? That's the answer. Alright. A circle radius r concentric with and outside the regular hexagon of side 2. There's no figure. Oops, no figure. Alright, regular hexagon of side 2, the probability that 3 entire sides of hexagon are visible from a random chosen point on a circle is 1/2. Okay, so good drawing is very helpful. Okay, when you make a drawing over here, this is hexagon. Is this hexagon? Okay. Do I have a hexagon drawing over here? No. Okay, that's fine. One more times. Okay, looks like hexagon, right? Okay. Correct. That's much better. Okay. All right. So when you have an outside of some circle over here, when you choose a point, we can see all 3 sides. Okay, and from here we can see all 3 sides. This side, this side, this side. All right. Okay. So we're gonna find out, okay, how big is the circle. So when you have over here, when you the line over here, when you straight line. When you have a right circle inside of here, right? Before over here circle, what happened? We cannot see. We can see only what? 2 sides, isn't it? Right? One side, isn't it? Okay. From here, we can see only this side. Is it okay?
Yep.
All right. So when you move over here, when you stand over here, any circle, this one. Okay, not over here, right? A little over here. We can see this side and this side or this side, right?
Yeah.
So when you have a make a graph, make a circle over here, you can choose any 2 point, any point. We can see by all 3 sides, isn't it? From here, we can see only one side, right? If you over here up to here, we can see only one side. This one. A little up here, we can see what this side, the other side. That's right, okay?
Okay.
All right, but only if we have the circles over here. We have a point, right? Choose point. We choose point on this circle, okay? From here to here, we can see all 3 sides, okay? But over here, the probability to visible, okay, 3 sides will be what? 1/2. It can be what? More big. Okay, it should be 1/2. Do you understand?
Yeah.
Okay, 1/2 means what? If this is big, we can see right over every side. Okay, we can see this side, this side, this side. Okay, or sometimes the other side too. Right? That is too much. So another side over here, we can see another over here. Here and here. This is same length. Okay. When you choose some point on these circles, we can see all 3 sides, isn't it?
Yeah.
So we have how many of this one? 1, 2, 3, 4, 5, 6, right? Okay. So actually, this is what we have 6 corners. 1, 2, from here to here, 3, and 4, and 5. And 6, right?
Yeah.
Okay, drawing is bad. So probability is 1/2. Okay, all 6 sides, we choose the length is okay. Okay, 1 side, 2 side, 3 side, 4 side, 5 side, and 6 side. Okay. All right. So this is your center, right? So to have 1/2, some of this angle should be what? sum of all these angles should be, when you add y, all these angles should be 180 degrees, isn't it? Altogether 360 to have a probability is what? 1/2. Okay, so we need what? 180 degree out of a 360 degree. That is 1/2, isn't it?
Yep.
True, right? But this is sum of the all angles. It's 180. That's 6 angles, equal angles. When you divide by 6, one angle should be equals what? 30 degree. It should be 30 degree. That's right?
Yeah.
Okay. Now the total is 180 degree, right? So from here, center, so here. You got 30 degrees. So from here to here, but this angle should be what? 30 degree. That's true, right?
Yeah.
Okay. All right. But a little, okay. So we're gonna find, okay, the length of what? The radius of circle, right? So this is R. We're gonna find this R, isn't it? Okay? We're gonna put this R, length. So the idea is what? Using this, we need to use these angles, okay? So you can make the root, okay, the method looks like this one. You can make the line over here. Okay, this is also R. Can you find this length? Can you find this length over here? Hexagon is what? The length is 2, right?
Uh-huh.
This is 2. Also this is 2. This is 2, right? Because that is what?
Yeah.
Equilateral triangle, isn't it?
Yeah.
Equilateral triangle. What is the length this side? Okay, I'm gonna make a little big, right? A little big. When you make the line, this is equilateral triangle, okay? This is 2, also this is 2, this is 2. This is center, we have another triangle. This also what? 2 to 60 degree, right? This is also 60 degree, isn't it?
Yeah.
Is that correct? Okay, because what inside is what? 360 divided by 60, this is 60 degree. Okay, so each one is 60, 60. This is also equilateral triangle, okay?
Okay.
So what is the length of this side? This side is what? This side is 1, okay? This is 60 degree. This side is half of this side is 1. And height is what? Red 3 times 1, right? This is a red 3, isn't it? We have another red 3 over here. So from to here, there is what? 2 red 3 over here, right? That is 2 red 3. Okay? Yeah, 2 red 3. Not red. 2 red 3. And also, can you see that triangle? This is a little bit, I make it too big, okay? When you make the line over here, this is each side, each angle is what? 15 degree, right?
Yeah.
Okay. So when you make the line over here, can you see that what is the measure of this angle? Can you see that? From here to here, how much? This is what? 15. This is what? 60 degree, half of this one, right? This is 30 degree, isn't it?
Uh-huh.
So at the other side, okay, 180 degree minus 30, this angle is how much? 150, right? Can you see that?
Yeah.
But one straight line over here, okay? Actually looks like this way. This is the graph, okay? Got a little complicated. This one is what? Equilateral triangle. Half of the divided by the angles, bisect the angles, each one is 30 degree, right? So the other supplementary angle is 150, isn't it? Because this is what? 15. This is this is also 15, right? So
Yeah.
15 plus 150, 180. This is kind of an isosceles triangle, right?
Uh-huh.
So this is 2 red 3. This is also what? 2 red 3. It's okay?
Okay.
Alright. Another one is when you make the line over here. Because this is 60, this is also opposite angle, vertical angle also 60, isn't it? This is also 60. Another equilateral triangles. This side is 2 red 3. Can you see that over here? They're a little bit complicated, okay? This side 2 red 3. This side is how much? Half of this hypotenuse, right?
Yeah.
Because that's a special triangle, it's 60 degree, right?
Mm-hmm.
This side already half of this hypotenuse, red 3, okay?
Okay.
Yeah, this is red 3. Now, almost done. Almost done. What is the length this side now? Red 3 times another red 3. It's okay? Do you remember?
Okay. Yeah.
Okay. When you have 60 degree, this is a 2s, this is a s, this is s times red 3, right?
Yeah.
Yeah, this is a red 3, s times another red, this is a 3. It's okay? From here to here is 3. Okay, now we apply Pythagorean Theorem again. Now big right triangles are there. We already big right. I'm gonna use the color to make it easy. This fine now. From here, all the way center, right?
Hmm.
I'm going to take the other side to complicate. I'm going to take the other side. Over here, okay? This side is what? Red 3. Okay, this side is R. Okay? From here to here, how much? We have a 3 over here. And from down here, another one is 2 red 3, right? 3 and 2 red 3. Is it?
Yeah.
Total is how much? Okay, I'm gonna make it. This is center. This length is what? 3 plus 2 red 3. This length is what? Red 3. This is R. It's okay? This is R.
Okay.
Alright. This is right angle. Now perfect. Now we can find R is the length of hypotenuse. Okay? Now let's find R squared. R equals square root. This was squared is how much? 3, right? This is square how much? 3 plus 2 red 3 squared, isn't it?
Mm-hmm.
Okay, now let's simplify this one. 3 plus 3 squared is 9. 2 times 6 times 2 red 3 is what? 2 times 6 is 6 and times 12 red 3, right?
Yeah.
And plus this is squared is how much? 12, isn't it? 2 squared is 4, 3 squared, let's go 3 squared is 3, right? So 4 times 3 is 12. That's it. Almost done. When you simplify this one, I'm going to write down over here. Looks like this way. 3 plus 9 plus 12 is how much? 24, right?
Yeah.
And plus 12 red 3. I'm going to move the numbers, some of the part of the numbers. Okay, except 2. 6 is what? This is what? 2, okay? 2 is in there. 6 is inside the move, okay? That is what is there. Inside the move, that is what? 36, isn't it? 6 squared again, right?
Yeah.
Times 3. So 36 times 3 is how much? 108. 2 red 108. Okay?
Okay.
How can you simplify? You know how to simplify this one? Maybe you better go over this one. Just give me 1 minute, okay?
Yeah.
Okay, we need this one. It's gonna be on next times, but we need this one, okay? Just give me 1 minute. Okay. When you have this one, like a square plus 2 red a times b plus red b square. Okay?
Uh-huh.
So what is this one? When you have this one? Okay? Inside is actually what is it? A square plus b square, isn't it?
Yeah.
Oh no, I'm sorry. A plus b, right? Not square. Radical a squared is a plus b. A plus b. And plus 2 red ab. That's true, right?
Yeah.
But actually this is what? When you use white squared, This is what is it? Root A plus radical B n squared. Is that the same thing, right? Do you remember this one? Looks
Yeah.
like what is it? X squared plus 2xy plus y squared equals what is it? X plus y squared, isn't it?
Yeah.
Okay, that's the same thing, right? Or instead of we use x squared, we use the what? Radical A, right?
Uh-huh.
Okay, so our radical A square plus 2 radical A, radical B, and radical B square. That is actually what? Rad A plus rad B square, okay?
Okay.
Same thing. But this can be move out, right? Square root A plus square root B, isn't it?
Yeah.
So this is actually inside radical looks like this way, okay? But when you have this form, it can be simplified this way. You know what I mean?
Mm-hmm.
Okay, we have just before we have right square root 24 over here. That's why I keep the white number 2, right? Over here. Inside the older number inside we got 108. Right?
Yeah.
So can you find two numbers? Product is 108. AB is 108. This is product 108. Sum of these two numbers is 24, isn't it?
Uh-huh.
Right? This is sum of two numbers. This is a product of two numbers. So we're gonna find two numbers, A and B. What is this number? Can you find out? Can you find two numbers to make
yeah.
right? What is that? Two numbers, maybe 18 and 6, isn't it?
Yeah.
Right? 18 times 6 is what? 108. A plus B is what? 24. That's true. We have two numbers over here. Okay.
Okay.
All right. Looks like this one. Now this will look like this one. 18. This was super. 18 squared plus 2. This is 108. Okay. 18 times 6 plus red. 6 squared. Same thing. Okay. But when you have this one just right, looks like this one. Okay, just one.
Okay.
The bigger number is the first. Okay, already. Square root 18 plus square root B. Okay, 6. Okay? Yeah, that's it. So how can you simplify over here? Square root 18 is what? Third, 3 red 2, and red 6. That is the value of R. Okay?
Okay.
Now back to work over here. When you have this one, always find the two number. That's why I keep the number 2 over here. All the other number 6 should be going inside one. Let it go again. Okay, we need this one. We need only 2. Okay, before what the radical. Okay.
Okay.
So from here we can say sum is 2 number 24. Product is 108. We can find A is 18, B is what? 6. Isn't it 2 numbers? Okay. When you this one move out, square root 18 plus square root 6. Okay, that is the value of R. We know that, right?
Yeah.
Okay, now the value of R is how much? 3 red 2 plus red 6, isn't it?
Mm-hmm.
It is okay. 3 red 2 plus 3 6. Choice distance, okay?
Okay.
Another one over here. If we have this one, A plus B minus 2 red A. But this is also working too. Just what? This is a minus. Okay, this is a minus. Looks like this one. X squared minus 2xy plus y squared, isn't it? This is
Yeah.
y. X minus y squared. Okay, but this is also what can be expressed as red A minus red B. But in this case, A should be greater than B. Okay.
Okay.
Because this is, we know that principal square root cannot be negative, right? Always, when you find two numbers, big one first, small one is next. It's okay? This is also what? 24 minus 200, 108. We know that two numbers is what, 18 and 6 number, but it should be negative, right? So square root 18 minus square root 6. Okay, in this case, the red 2 minus red 6 is the answer, okay?
Okay.
You have to remember, right? Okay. Maybe next, anyway, we're gonna go over this one more time already. Okay, next time, okay? Not next time, okay? When it's the time, this is a little later, okay? Yeah.
Okay.
Or maybe if you are strong in trigonometry, okay? If you're strong in trigonometry, you can use the right trigonometry. Because this one is 15, right? Sine 15, we know that over here, we have very simple number over here. Red 3 and R, right?
Yeah.
Because we don't have to find this length. Sine 15 equals how much? Opposite over R, we need this one, right? No, hypotenuse, right? That's right. Red 3 over R, it is very simple. Right? If you know that, right, the value of right sine 15. Okay. What is sine 15? Do you remember sine 15 is what? Sine 45 minus 30 using two special angles. We can express 15, right?
Yeah.
This
So
is sine 15. What is this one? Sine 45.
the
Cosine
square root
30.
2.
Yeah. Cosine 30. This is minus. And cosine 45 and sine 30. That's the equation identity, right?
Mm-hmm.
Sine 45 is what? Red 2 over 2.
Uh-huh.
Cosine 30 is what? Red 3 over 2. Cosine 45 still red 3 over 2. Sine 30 is 1 over 2. Right? Sine 30 equals cosine 60, which is what? 1 over 2, right? When you simplify this one, 4, common denominator 4, 2 times 2 is 4. Numerator 2 times 3 is red 6 minus red 2. This is the value of what? Sine 15. Right?
Okay.
So R equals, you can switch any times. R equals what? Red 3 over this one. Right?
Yeah.
Red 6 over red 2 over 4 is what? Times 4, same thing, right?
Uh-huh.
It's okay. Now you need to simplify. Times red 6 plus red 2. Oh, this is also a lot of work, right? We need to multiply the conjugate, okay? Red 6 minus red 2. Wow, it's a lot of work too. This is a minus b, a plus b, right? A squared minus b squared, okay? So 6 minus 2 is 4 over here, right?
Mm-hmm.
But 4 is cancelled out, that's fine. We just multiply these two. Red 3 times red 6 is red 18 plus red curve 3 times the red curve 2 is red curve 6. Same as before, right? So 3 red 2 plus red 6. Okay?
Yeah.
Now you can solve this way if you are strong in trigonometry, okay?
Yeah.
Alright, number 12. A lot of tangent, right? A lot of tangent. These two lines are also right common tangent line over here, okay? So which is the radius is one is small, one is 4, the other one is 9. So we have tangent line. This is y equals m x plus b. Slope is m, y is b. But m is positive. What is the value b? We're gonna find right the value b. Y-intercept this point is what value b, isn't it?
Mm-hmm.
Okay. Now let's find this one. How you find? How you find? We're gonna find the slope and what point. To find what this point b, actually we need what we need. Slope. Right? This one and a point, isn't it? And a point. Put this point right into the equation so you can find the value of b, right? First algorithm, how you find the slope of this line. Slope of this line, how can you find this one? Wow. You can make the line of it. The tangent, okay? The length this one, the length this one, they are equal. right?
Yeah.
That's true. And also when you make the line, this line pass through the tangent, right? So, isn't it in the middle, right? That's okay. Right. If this angle is theta, the other angle is also theta, right?
Yeah.
Okay, because this is a tangent. Okay, when you have tangent, this is a tangent in center, or with the bisect what the angles. Okay.
Okay.
Okay, we need one point. This point. Oh, this point is okay. Or other point that we don't know, right? We need this point. Okay, x-intercept. Okay, and also we need to find the slope. What is slope? Can you find the slope first? Oh, this one is a little hard. Okay. What is okay? Slope is what is there? When you have the line, slope is what always equals what tangent theta. This is another trigonometry, tangent theta. Okay, when you have the angles over here, right?
Yep.
Tangent theta is opposite over adjacent. That's the slope, isn't it?
Yeah.
It's okay. Tangent theta, that is equals what slope, and it's same things. Tangent y over tangent x. Okay. What is the slope over here? Well, maybe you can use these two lines because you are between any 2 points. It has what same slope, right?
Yep.
This slope, is same thing. Okay, you're gonna find this slope. How much this one? 9 minus 4 is 5. This length is how much? 14 minus 2 is what? 12, right? Slope is how much? 5 over 12. Okay. This slope is what? 5 over 12. But we learned this one. Okay, using this anyway. Okay, now do this way. Using this one, we're gonna find this point first. Okay. All right. What is the equation of this line? Well, you can use what slope. This is okay too. Okay, I'm gonna use what similar, right? At this time, I'm gonna use the similar. Okay, similar. This triangle, the other triangle are similar, right? So if this is 5, this is what? The length is 12. If this is how much? 4, isn't it? Right?
Yeah.
This is 4. What is the length of this one? Can you find this length? 5 over 12 equals what? 4 over, I'm going to do this with D. 4 over 12. 4 over D, right?
Yeah.
It's okay? Yeah, this is working too. 5D equals 48. When you divide by 5 and divide by 5, 5 equals what? 9.6. This is 9.6. What is this point now? 2 minus 9.6, right?
Yeah.
Because that distance is 9 points, but this coordinate is 2. You're gonna find this point of right coordinate, right? So 2 minus 9.6 was negative 7.6, isn't it? This is what negative 38 over over 5, right? It's okay? Yeah. Negative 38 over 5 in fraction, okay? Okay, now we got the 1 point already. This is x-intercept is negative 38 over 5 and 0. We got 1 point. Now we need to find the slope of this line. Slope of this line. Not this one, okay? Alright, slope of this line is tangent to theta, isn't it? Same thing. Slope of this line equal, I'm going to use this space. Tangent to theta, right? By definition. Okay?
Okay.
Right. Just obvious. Slope this way. Tangent to theta. Twice. Right? Okay. But we know that tangent theta is how much? We just find the 5 over 12, right? Tangent to theta, can you express tangent to theta what in terms of what tangent theta? Do you know? Okay, for example, now let's go over, okay, this one just one more time. Okay, where is the no, just where is that? You need to memorize this, okay? Double angle. Sine 2 theta is how much? 2 sine theta times cosine theta, right? You remember this, okay?
Yep.
The second one is cosine 2 theta. This is what we have 3 different ways: cosine square root theta minus sine square root theta, or 2 cosine square root theta minus 1, or 1 minus 2 sine square root theta. Do you remember this one? Double angle, okay?
Okay.
Yeah, because what this one, if you want to express in only cosine, you know that cosine square root theta, sine square root theta is 1 minus cosine square root theta, isn't it? Do you remember? Sine square root theta plus cosine square root theta equals 1, right?
Yeah.
This we say Pythagorean identity, isn't it? So
Uh-huh.
you can sine square root theta always can be expressed 1 minus cosine square root theta. Okay, from here you can see this way. Okay, all this one is what? Same thing, Pythagorean identity. Okay, but it's what? Different expression. Okay, it's the same thing.
Okay.
Another one, tangent. Tangent to theta can be expressed this way: 2 tangent theta over 1 minus tangent square root theta. Okay, you need to memorize all these 3. Okay?
Okay.
Because what tangent theta 1 plus theta 2 can be expressed this way: tangent theta 1 plus tangent theta 2 over 1 minus tangent theta 1 tangent theta 2. By this time, theta 1, theta 2 is equal, right? Theta 1 equals theta 2, isn't it? That's why we
Yeah.
got what? Tangent to theta. Okay?
Mm-hmm.
Tangent to this is theta, theta is what? 2, okay? Twice
Okay.
of tangent theta. 1 minus tangent theta, another tangent theta square is what? Tangent square root theta, right?
Yeah.
Remember this. Also, we have a different angles. This is a double angle, but different angle means what? Sine theta 1 plus sine theta 2, right? Do you remember this one too? Sine theta 1 times cosine theta 2 plus cosine theta 1 times sine theta 2. You need to memorize, okay? If
Okay.
this is a minus, if this is a minus, this is also minus. Okay?
Okay.
And also we have what? Cosine also. Cosine theta 1 plus cosine theta 2. A little bit different. Cosine theta 1. Cosine. Cos. Okay? Same
Okay.
3. This is plus, this is minus. Sine theta 1. Sine theta 2. Okay? If this is a minus, then this is a plus. It's okay? So when you have right 2 angles equal, what is that? Cosine, this is angle theta, right? 2 theta, isn't it? What is
Yeah.
it? Cosine theta, cosine square root theta minus sine square root theta. It's the same thing, okay? From here. This
Okay.
also what? Equals to what? Theta. Sine 2 theta is how much? Sine theta, cosine theta, same angle, right? Cosine theta have same angle. So that's the same thing, okay? So 2 times what? Sine theta, cosine theta, isn't it? So you have to memorize over here, okay? You need to memorize. Okay. Now go back to work again. Tangent to theta, we know that 2 times tangent theta. Wait, I didn't write down. Okay, 2 times tangent theta, right? Tangent theta is already over here. Given, right? 5 over 12. It's okay? 5 over 12. Minus 1 minus tangent square root theta, right? Tangent square root theta, right? 5 over 12 square root theta, right there. 25 over 144, isn't it? It's okay?
Yeah.
Because, okay. This is exactly what? Tangent theta, right? Slope. Square theta is what? 5 squared 25, 12 squared is 144. Okay? Then you go simplify. 144 over 1 is 144 and minus 25. 144 minus 25 is what? 119, right? So
Yes.
this is 119 over main bar. This is what? 2 times 5 is what? 10 over 12, but we're gonna find the common denominator, right? 144 times 12 times 12, 120, right?
Yeah.
144 over 120. Okay.
Okay.
120. That's why the slope is how much? 144, 144 out. Slope is what? 120 over 119, right? Yeah, we
Yeah.
got to find the slope over here. So the equation of this, like this is a little bit hard. This is about number 19. Now set up the equation. Okay, y equals m is what? 120 over 119 x n plus b, but this is gonna pass through the what? This point, negative 38 over 5 and 0. That is what x-intercept. Wow, a lot of work, right?
Yeah.
But actually, if you understand the questions, you can go quickly, okay? You can
Okay.
go quickly. So put this number into the equation. Y equals 0. X equals what? Negative 38 over 5, right?
Yeah.
And plus b. This is y-intercept. So b equals how much? 120 over 119 times 38 over 5, right?
Yep.
That's okay? Alright, now simplify this one. This is 1, this is what? 24, right?
Mm-hmm.
Wow, this is a very big number. Okay? Alright, 119 times 1 is what? 119. Okay, maybe possibly we got 119 3 over here, right? Now
Yeah.
simplify over here. 24 times 38. 24 times 30, that's 192, and 72, 912, right?
Yeah.
Okay, that is 912. Oh, we got that answer, okay? So choice is that's okay?
Okay.
Alright. This one is why if you need the trigonometry, okay?
Okay.
So AMC 12 need a lot of strong trigonometry background,
Yeah.
right? So each questions you have to memorize all formulas and theorem, okay?
Okay.
All right. Actually, this is number 1912A, okay?
Okay.
All right. Now move on number 13. Okay, a circle with the center is tangent to the positive x-axis, externally tangent to what is that? No figure again? Okay, so AMC, we need to draw it, okay? Many times. They better give right the drawing. They don't give right too much drawing, okay? A
Yeah.
circle with the center tangent externally. Center is 3 and 0 here. 3 and 0. This is center with the radius 1. Okay. Radius is 1. It's a circle. And what is some of our possible radii of the circle C? Circle C is tangent to the x and y, and dictionary tangent. Okay, tangent x is what? Over here, right? We're gonna find this one. So this is what? Here tangent. So this way, right? Okay.
Yeah.
A little weird. But we're gonna find the radius of here, right? Anyway, this radius, this center always as I told you, we're using the center, right?
Uh-huh.
Okay, this is r plus 1, isn't it? This is r plus 1. Okay. So what is the possible value of what? R, right?
Yeah.
Okay. Okay. This is a bit weird. This looks like this. This is better, okay? This is down of a perpendicular, okay? So we got one right triangle, okay? We're gonna use this one right triangle. Okay. This already we got the 1 r plus 1. This is what? R, isn't it?
Yeah.
What is the length this one? from here to is r, from here to is what? 3 minus r, right?
Yeah.
Okay, 3 minus r, that's fine. We just got all three sides in terms of r, right? So using Pythagorean Theorem, you can find the value of r. Okay. So we got over here. What is Pythagorean Theorem? R squared plus 3 minus r squared equals r plus 1 squared. We might have two value of r, right? Because this is the quadratic. So another one, okay, I think there are two value. Because this is square, right? Another one looks like this way. If this is 3, will be another one is the bigger one. A tangent x and y, okay? It's okay? Yeah, this is also what? R, isn't it? This is what? Maybe this is 1 to make it the line. This also what? R plus 1, right?
Yeah.
It's same thing. Oh, okay. Now much easier. We don't have to write calculate separately, okay? The next this is also what is there. At this time, this is what? R minus 3. This is 3 minus, that's different. This is R minus 3, okay?
Okay.
Right. This is still R, same. The only thing is what R minus 3 and the 3 minus R, that's different. We're gonna make right absolute value, okay? Alright. But it doesn't matter. Oh, okay. It doesn't matter. When you make a square, R minus 3 radical square is what? R minus 3 square, okay? Same thing.
Okay.
You can say it any times. 3 minus R square is same thing. Okay? So we can find this value of R from here, alright? In this equation. Okay, so that's why they gave us what? Two different values of R, right? Which is a quadratic equation, okay? Okay, now let's find two values of R. That's fine. Because this is that indicate what this equation and the other equation, okay? It includes both, okay? Alright, now let's find. R square, much easier than before that. This is 3 square is 9 minus 2 times 3 times negative is 6r and plus r square equals what is that? R square right hand side r square plus 2r plus 1, isn't it? We got two values r already. So r square is out. So we got to what? Simplify. R square 2r negative 6r negative 2r, right? So negative 8r, isn't it?
Yeah.
So 9 minus 1 is what? Minus 8. Okay, plus 8 equals 0, okay? That's fine. That's the equations. But over here, sum of all possible radius, sum of all possible this value of r, this value of r. Okay? It was here. You know the Pieta's formula, right?
Yes.
Sum of the two root equals to how much? Sum of the root is what? Negative b over a, isn't it? Alright? So sum of root is over here, 8. Okay? So R1 plus R2. I'm going to, this is R1, this is R2. Okay, so R1 plus R2 is what? Negative 8 over 1 is 8 each distance, okay?
Yep.
That's it. Choice distance. Okay, this one needs a lot of work too, okay? But you need a good drawing, okay? You need to figure out, okay, we have two different possible cases, alright? From here, we can say r squared, oh, there must be two different values of y. The other value of r can be obtained from this figure, okay? So we have to figure out these two. Alright, the next one, number 14. How many integer value of k does to what? Okay, I'm gonna delete this one, okay?
Okay.
This is recording, but I don't know where is the button, maybe. What if I lost the recording? X squared plus y squared equals k squared is what? Circle, right?
Yeah.
K is positive, this way. If k is positive, So graph, this is k, right? What is xy equals k? This is what? Rectangular y hyperbola. Okay, it looks like this way. I'm going this way. It's okay. This is what y equals k over x, isn't it?
Yeah.
All right. Another one is k is negative. If k is negative, what happens? You have two possible, right? K is negative. Now radius is negative k, right? Now radius is negative k. Negative k is what? Radius. It's okay because k is negative, right? So negative. This one is negative k. It's okay.
Yeah.
This negative k, the graph looks like what is it? Here and here, isn't it? Positive here and the other side. It's okay. If we have this one, xy equals 1 over x. The graph of this one is one is here, the other one over here. Okay? And y equals to negative 1 over x is what? Here and here. Okay? We have two different ways. Okay. This one is not intersect. This is what ejective symmetry with y equal x axis. Okay.
Okay.
This point. So this is your length is radius is k, right? What is length from here? This one is x times y is k. This point is what? Red k, another red k, isn't it?
Yeah.
Alright, that's fine. What is the length of this side? From here to here, the length of this one is what is that? This is what? D1 is k, D2 is what is that? Use right Pythagorean theorem again, right? D2 equals what? Square root. This one square, k plus another square, k equals what? Right, 2k, right?
Yeah.
Okay, not to have an intersection, this length is what? Greater than this one, right? It's okay? Right? Because length was greater, okay? So, do not have an x-intercept, so red 2k should be greater than k, isn't it? Yes, that's correct, right? Okay,
Yeah.
now make a square because k is a positive, it's okay. So 2k equals what? Greater than k squared. How can you solve this one? K squared minus 2k less than 0. Okay, I'm gonna do the less than the same thing. Okay. So can you factor this one? K out, k minus 2 inside the parentheses less than 0. Always less than 0 is between 2 points, 0 and 2. The graph looks this way, less than 0, only this one, right? Okay, so k should be what? Greater than 0 but less than 2, isn't it?
Yeah.
Do you understand this one? Okay, you know the right how to solve the right inequality, okay? Alright. So we have our only integer numbers. Between 0 and 2 only what? Integer number x is 1, right? K is 1, I'm sorry. K or 1 available, okay?
Okay.
But in this case, we eject symmetry, it should be what? In this case, it should be what? K equals negative 1. It's okay? That's symmetry. So we don't have to solve this one. Eject the same situations, but the only thing is that k will be negative number. We have two possible valuable x, okay? So a possible value of k. So choice C is this, okay? K value is what? 1 or negative 1, okay? Alright, that is number 14. Alright, now take number 15. So we have the radius 3 and 8. This is 3. This is red tangent, okay? This is 8. That's fine. We have a common internal tangent intersect the circle C and D, right? Yeah, that tangent, so that must be what? Perpendicular, right?
Yep.
Alright, so AE is 5. This is 5. You know that these two triangles perpendicular, right? To the same line, they are perpendicular means what? They are parallel, isn't it?
Yeah.
Right? So same line perpendicular, they are parallel. This line is parallel. So this is vertical angles, they are congruent. Parallel is what? Also this is another angle, okay? We got another right angle already. So angle congruent triangle, you can see that triangle ACE and triangle BDE, right? BDE are similar, isn't it?
Yep.
They're similar, right? Corresponding sides similar. But to find the length of CD, just find out these two lengths. This is 3, 5, this one should be 4, right? Right triangle triplet. Okay, 3, 4, 5. But this is 3, this is 8. Okay, corresponding side is what? 3 to the 8. Or other one is still 3 to the 8. Is it okay?
Okay.
So this corresponds always to 8 over 3 times, okay? You can use your dilation factors or scale factor. Scale factor S equal how much? 8 over 3, didn't it? From here to here, right? Every side, every corresponding side is what? 8 over 3 times 4, this corresponding side, times 4 times 8 over 3 times 32 over 3, right? This is the length. It's okay? Alright, that's it. We need to find the length of a CD only, right? So 4 plus 32 over 3 equals 12 over 3 and plus 32, right?
Yeah.
So which is what? 44 over 3 times, okay? Yeah, we just use what? Similars. Okay, and tangent. Okay? Alright, that is number 15. Alright, number 16. Oh. Alright, anyway, we need the questions anyway. So which of the following describes the graph of this one? What is this? What is this graph? Looks like complicated. What is this one? Can you figure out what it is? Oh, we can't. Okay, so complicated because there are many like terms there. Okay, to find something, so you need to simplify. That's the idea, right?
Yeah.
Okay, now let's simplify. I need a space over here. So xy squared, what is that? X squared plus 2xy and y squared. That is equals x squared, y squared. Oh, two terms cancelled out. X squared out, y squared. We just got what? Simplest one. 2xy equals 0. What is this figure? What is the solution? Zero property, right? You know the zero, right? Zero product. This we say zero product, right? X is 0 or y equals 0, isn't it?
Yeah.
What is x equals 0? X equals 0 is 1. Y axis, this is x equals 0. Where is y equals 0? This is y equals 0. Actually, what? Two intersect lines. Okay, two lines. Okay, choice sequence. Okay, this is not hard. Okay. Alright, number 17. Another circle, also a tangent. Always what? The radius or diameter and to the tangent always perpendicular, right? So these two lines are always parallel. Okay. We have a common external tangent. What is the area of a hexagon? Hexagon where is AOB, here, 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 here. Okay. All this area, right? This is exactly what equal, right? So just find out what AODP, that's okay. Right? After that you multiply by 2, right? So the best way is this is right angle, you can make it right divided two different way. Okay? Or you can use this one as what? Trapezoid, it doesn't matter. Because what AO, DP are parallel. This is perpendicular, right? Okay, this is trapezoid, okay? You can see that AOPD is a trapezoid. You can use right the formula for trapezoid. Base 1, base 2 times height. Where is the height? This is height, or this is height, and divided by 2. That's the area of this trapezoid. Because we have the other trapezoid over here, times 2 again, that's it. But the only things we need what? The height. Where is the height? Can you find this one? 6, isn't it? 2
Yeah.
plus 4 is 6. What is the length of this side? 4 minus 2 is what? 2, right?
Uh-huh.
Okay, what is the height of here? Using Pythagorean theorem, this side is a square root. 6 square, hypotenuse square, 36 minus 2 square is 4, right? That's the height. This is h. This is h. It's okay? Or you can separate, okay, one is a rectangle, the other is a right triangle. It doesn't matter, okay?
Okay.
Right, you can do that. Anyway, we need the height, right? Height is what? Square root 32 is what? 4 rad 2, isn't it?
Yep.
This is equals 4 rad 2. You can do that, right? Rectangle is 2 times 4 rad 2. And triangle is what? 2 times 4 rad 2 divided by 2, okay? That's fine. But I'm going to use what? This way, trapezoid. Okay? So h equals 4 rad 2. This is what? 4 rad 2. 2 plus 4 is what? 6 times 4 24 divided by 2 is what? 12 rad 2, isn't it? It's okay. This is 6 times 4 rad 2 and divided by 2, right? 12 rad 2, right? Times 2 again. Okay, maybe you can cancel it out. Okay, times 2 again. 24 radical 2 is the answer, okay?
Uh-huh.
All right. 24 radical 2. Choice B is the answer, okay? We cannot finish this one today. Okay, Nick, you can try this one 18. Maybe you can take a look, right, the answer key, okay? So
Okay.
answer key, you can go to right, what is the AOPS, internet. You can take a look the answer key, okay? Try this one number 18 by yourself. We're gonna go over next time, okay? All right,
Okay.
18, because I have another class after this, okay?
Yeah.
Some sort of very emergency case over here. He has the test tomorrow.
Mhm.
We have this one. So number 19 and 20, we cannot finish this one. But each question is very important, okay? So we cannot finish right, how to find the inner point. We can do finish this the next time, okay? Inner point out. Okay.
Okay.
Okay, this one. Okay, I'm gonna find out about decoding, okay? I'm gonna send out, okay?
Uh-huh.
During the next class, between the break time, okay? I'm gonna make a video. Okay, any questions over here? So how would your school work? You're taking what course? Algebra 2, right?
Yeah, algebra 2. We just got into trigonometry.
Oh, you just started trigonometry. Okay, you have to completely okay, figure out the log and trigonometry, okay?
Yeah.
This is very important. And also what you can do binomial expansion theorem.
Okay. Yeah.
Okay, this is very important, okay, on AMC, okay?
Uh-huh.
Alright, okay. Now let's finish today, okay? I'm gonna send
Okay,
out
yeah.
the video, okay, after I make a video, okay?
Yeah.
Alright,
Okay.
thank you so much for joining class, okay?
Okay. Yeah.
Okay,
Thank
I'll
you.
see you next time, okay? Bye.
Bye.